Dear students, today I am going to start a new chapter, probability. In your previous class, already you have learned so many things about this probability. We have to discuss some more concepts related to probability. The words already you heard, those are probably, means an example of you. Today, probably rain comes, means it may or may not. It may or may not. Probably means may or may not. We can't say accurate exactly. Chance, the word chance is 50-50. So either the team A or team B. So which one will win? Whatever chance is 50-50. Probably, most probably, chance, those words already you heard in your previous class. Next, certain means accurate, uncertain, we can't. Okay? So such type of words are there. First, I'll discuss what do you mean by probability. Okay? Probability is a measure of uncertainty. Uncertainty is, it is uncertain, not certain, not accurate. We deal with those situations in which a particular result or outcome is not certain, means not accurate, but it can be any one of the several possible outcomes. Possible outcomes. Once again, probability is a measure of uncertainty. It is a measure of uncertainty. We deal with those situations in which a particular result or outcome is not certain. Not certain means not accurate, but it can be any one of the several possible outcomes. I will say one example. If you have to toss a coin, the outcomes are either head or tail. Getting head is one outcome and getting tail is other outcome. So we can't say particularly, but one of the our outcome is not certain, but it can be any one of the several possible outcomes. Either you may get head or tail. So it can be any one of the several possible outcomes. So possible outcomes to toss a coin are either head or tail. If you take one more example, you have to throw a dice. Outcomes are, possible outcomes are 1, 2, 3, 4, 5, 6. Those are possible outcomes. Out of those, one may come. If you have to throw a dice, the possible outcomes are 1, 2, 3, 4, 5, 6. So it can be any one of the several possible outcomes. It is a measure of uncertainty. We deal with those situations in which a particular result or outcome is not certain. We can't say particularly, but it can be any one of the several possible outcomes. We can say this. Next, experimental or empirical probabilities. What do you mean by experimental or empirical probabilities? Just to see the probability that are based on the result of actual experiments. Means actual experiments are nothing but tossing a coin, throwing a dice, taking a card from a separate deck of 52 cards. Like these are the experiments and adequate recordings of the happening of the events. Adequate means you can't say particularly that one. Recordings of the happening of the events. Event is nothing but outcome here. I will discuss those words terms later. Okay, so experimental or empirical probabilities are nothing but the probability that are based on the results of actual experiments. Like result of experiments, nothing but so getting head, getting tail. If you have to throw a dice, 1, 2, 3, 4, 5, 6. Those are actual experiments and adequate recordings of the happening of the events. Means so what the outcomes will appear those. So this is the experimental or empirical probability. I will discuss later in detail later. Next, theoretical or classical probability of an event E. This is most important here. Probability of an event E is nothing but event here. Event means outcome. Like if you have to get a head or tail when you toss a coin, that is getting head is one event, getting tail is another event. So probability of an event E is nothing but what? This is most important. That is equal to number of outcomes favorable to E. Favorable to event E is nothing but favorable is getting head, tail if you toss a coin. Those are favorable to E. Divided by total number of outcomes. If you toss a coin, so getting head is one outcome, that is a favorable. Either getting head or tail, those are favorable outcomes. The total number of outcomes are head, tail, 2. So like probability of an event is equal to number of outcomes favorable to E or total divided by total number of outcomes. You should remember, this is the most important thing. Next, some words are discussed here. Experiment. I said experiment. Experiment is an operation which can produce some well-defined outcomes is called an experiment. Experiment is some words I said already. Experiment. If you toss a coin, that is one experiment. Okay? An operation which can produce some well-defined outcomes is called an experiment. If you throw a dice, that is also one experiment. So in that experiment, outcomes are 1, 2, 3, 4, 5, 6. Okay? So all these belongs to experiment. Okay? Experiment is nothing but it is an operation which can produce some well-defined outcomes is called an experiment. Now I'll discuss some more definitions belongs to the probability. That is the first one, random experiment. It is an experiment which when performed produces one of the several possible outcomes is called a random experiment. Random experiment means in an experiment one possible outcome. So many possible several outcomes will be there. So an experiment which when performed produces one of the several possible outcomes is called a random experiment. I hope the word random word, a random test. Okay. And next definition is event. What do you mean by event? The outcome of an experiment is called event. Like getting head. If you have to toss a coin, getting head is one event, and getting tail is also one event. If you throw a dice, getting 1, 2, 3, 4, 5, 6, all those are events. Okay? Nothing but what outcomes. Next, trial. Trial, already heard this word also. It is an action which results in one or several outcomes. Trial means if you try, means you have to toss a coin, you may get head or tail, that is a trial. Example, each toss of a coin is called a trial. Each toss of a coin is called a trial. Means, so you toss once, you may get head or tail. So each toss of a coin is called a trial, and each throw of a die is a trial. Each throw of a, so die is also a trial. Either you may get any one outcome. And next, equally likely events are equally likely outcomes. This is important. If we can reasonably assume that each outcome of an elementary experiment is as likely to occur as the other. For example, if you toss a coin 10 times, you may get 4 to 5 times head or tail. So getting head and getting tail are equally likely, means nearly same, equally likely events. If we can reasonably assume that each outcome of an elementary experiment is as likely to occur as the other. For example, if you toss a coin, getting head or tail, so may equally likely. It is nothing but if you have to increase the numbers, you may get equally likely. Give example. If we can reasonably assume that each outcome of an elementary experiment is as likely to occur as the other, we refer to this by saying that the outcomes head and tail are equally likely. Means if you do an experiment like tossing a coin, so 10 times, 50 times, 100 times you increase the number of outcomes. Head and tail you have to note down separately. So getting head and getting tail may equally likely, means nearly equal. Not exactly but nearly. One more example. The equally likely outcomes of throwing a die are 1, 2, 3, 4, 5, 6. Means if you throw a dice, so what are the possible outcomes? 1, 2, 3, 4, 5, 6. There also have to note down number of getting 1, 2, 3, 4, 5, 6. There also you will get equally likely outcomes. One more, sample space. Yes. What What do you mean by sample space? Is the set of all the events that could be associated with an experiment is called its sample space, denoted by S. It is nothing but what? The set of all the events that could be associated with an experiment is called its sample space. It is denoted by capital S. Example: a coin is tossed, S is equal to head, tail. So you have to write in the bracket. It is nothing but set. So if you have to toss a coin, what are the outcomes? Total number of outcomes: head, tail. Two coins are tossed simultaneously. S is equal to, so two toss or coin, two coins are tossed. Either you get head, tail, head, tail, and these are the outcomes. Total number of outcomes. If you toss three coins, head, tail, like total outcomes, how many will be there? You have to write down based on the given. One more example: a line is thrown, S is equal to, means sample. Using previous definitions, I'll discuss some questions, examples. Example number 1: a coin is tossed 1,000 times with the following frequencies. Frequency is nothing but how many times the particular entry or particular number occurs. Yet 455 times. Tail 545 times. Okay. A coin is tossed 1,000 times. The following frequencies are: yet 405 times occurs, and tail 545 times occurs. Compute the probability for each event. Means find the probability for each event, head and tail. Solution: total number of outcomes 1,000 here. Let number of getting head be E, means capital E we have to consider, and tail be F we have to consider. Therefore, the probability of E means getting head is number of favorable outcomes. Here, favorable outcomes are E we consider heads, so number of heads divided by total number of outcomes. So already you have written this formula. Okay, number of heads divided by total number of trials, total number of outcomes. That can be written as P of E. It can be written as P of E is nothing but probability of getting E, means head here. That is equal to 455 times head given. So 455 divided by 1,000, that gives us, write this one. It is equal to 0.455. 0.455 is the probability of getting head. Similarly, we can write probability of F is probability of getting tail is equal to number of tails divided by total number of outcomes. That is 545 divided by 1,000. That gives us 0.545. So these are the probability of getting head and tail. Now we have to add these two: P of E plus P of F. P of E is nothing but probability of getting head. Probability of getting tails, that is equal to 0.455 plus 0.545. That gives us, sum gives us 1. Always this will be equal to 1. By using this, I'll take one more example. Later I'll come to one more example by using the previous definitions. Two coins are tossed simultaneously. That means one by one, 500 times, and we get two heads, means HH 105 times. One head means head tail, like 275 times. No head means both tail 120 times. Find the probability of occurrence of each of these events, means these three events. Let us consider, let us denote the events of getting two heads. First condition, be even, one head. Second condition, E2, and no head, E3. E1, E2, E3 you have to consider capitals. Therefore, probability of getting E1 means two heads is equal to number of favorable outcomes 105 divided by total number of outcomes. Simply we will get 0.21. Similarly, P of E2, that is nothing but probability of getting one head. Number of favorable outcomes divided by total number of outcomes. One head is 275 times divided by total number of outcomes of 500. Simplify this one, it gives us 0.55. Probability of E3 means P of E3 is probability of getting no head, means just tails. So 120 divided by 500, that is 0.24. Sum of these three. Now P of E1 plus P of E2 plus P of E3 is equal to 0.21 plus 0.55 plus 0.24. Add these three, it gives us 1. It gives us 1. By seeing these two examples, not only these, given so many examples, you have to see in your textbook. We have to conclude. Take one note. The sum of the probabilities of all the elementary events, means P of E1, E2, E3, all these are elementary events of an experiment is always equal to 1. Means sum of all those, how many elementary events will be there? If we add all those, it gives us 1. So P of E1 plus P of E2 plus P of E3 plus P of E4 and so on up to P of En is equal to always 1. How many elementary events will be there? Sum of all those will be equal to 1. By using these examples, some more examples given in textbook, just you have to check, see those. By using all these, I will start exercise, first exercise in next class.